Assalamualaikum warahmatullahi wabarakatuh. We are from Group C from class Bmmv 1-2. So today we would like to present the pressure in pipe. These are my group member. First, Muhammad Irham bin Zailan, Muhammad Ifat Hakim bin Muhammad Rawi, Muhammad Asrul Hasan bin Haris, Muhammad Nasrul Aiman bin Muhammad Zulkarnain, and last, Muhammad Mukris Ammar bin Alias.
Assalamualaikum and salam sejahtera. Today our group will present about the pressure in pipe based on a hose pipe system. We have conducted a research to study the type of configuration system, which is closed loop system and the other one is straight line system. By using the daily life equipment such as hose pipe, T-connector, measuring cup and stopwatch, we have set an experiment to study this application system then compare it with the computer simulation. The aim is to perform experimental and simulation flow exercise in the hose pipe. Our goal is to analyze variation unknown in hose pipe with two different configuration and application of Bernoulli equation. For the task 1, we will conduct an experiment using application with the figure 1 given. Place a thumb to cover a part of the hose outlet to create water jet flow outward. After that, we measure the maximum height of the water jet. Here is our actual video on experiment and collecting data.
Orang sana report. Okey. Alah.
Memang kena basuh.
Sama tinggi kan tu?
For the outcome, first set a reference point to the system. Inside hose pipe will be set as a point 1 and the outlet of the hose is set as point 2. After that, we calculate the flow rate of the experiment. Open the valve check until the maximum position, then record the volume and time taken. We measure the time taken to fill up to 500 ml of volume of water. The flow rate was given by volume per time taken. Flow rate is 1.9685 times with 10 power of negative 4 meter cubic per second. Then find the velocity. The flow rate V dot also equal to velocity time with cross-sectional area. The flow rate is the same. Flow rate V dot 1 equal to V dot 2. So U1A1 equal to U2A2. The velocity U equal to 1.1140 meter per second. Velocity is the same, so we can consider the flow rate is the same. Next, the height of water jet measured for the experiment is 165 cm or 1.65 meter. Finally, to find the pressure in pipe P1 using the Bernoulli equation as shown given. Sign velocity is same, so it can be cancelled out at both sides. The reference point Z1 equal to 0 also can be cancelled out. So here is our final equation. The pressure in pipe P1 is equal to 117.5115 kilopascal. That's all from me. The presentation will be continued by my group mate. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ifat Hakim bin Muhammad Rawi from Bmmv 1-2. I will explain about experiment 2, which is the straight line water configuration. The content of this experiment is to find the volume, flow rate and the velocity. This is the cross-sectional area for hole, 7.07 times 10 power of negative 6 meter square. The volume flow rate formula is Q equals to volume over time and the formula for velocity is U equals to Q over A. This is the picture of the sketch and the original one of the pipe that we have done. The pipe is 2.5 meter long and have 3 holes A, B and C. This is the video during conducting the experiment.
Tiga. Satu, dua, tiga.
Dua, satu, dah.
As we can see, one of my friends are taking the reading of the water in the jar and one of them set the timer for 3 seconds.
Tiga.
This is the data of volume collected in 3 seconds. For hose A, the volume is 0.32 liter, for host B 0.28 liter, for host A, for host C 0.25 liter. After that, we convert the volume in liter to meter cube. So this is the result. After we get the volume, we can calculate the volume flow rate and the velocity. This is the sample calculation for volume flow rate, and this is the sample calculation for velocity. This is the data that we have get from the calculation. The volume flow rate for host A is 106.67 times 10 power of negative 6 meter cube over second. For host B, 93.3 times 10 power of negative 6 meter cube over second. And for host C, 83.3 times 10 power of negative 6 meter cube over second. And the velocity for host A is 15.1 meter over second and 13.2 meter second for host B, and for host C 11.8 meter over second. We can conclude that if the flow rate of water increase, the volume collected in 3 seconds will increase. This means water take lesser times to fill the jar when flow rate of water increase. If the cross-sectional area of hole decrease, the flow rate will decrease. Okay, that's all from me. Thank you. Next, we move to next part.
My name Muhammad Hasrul Hassan bin Haris. I would like to present task 2B closed loop water hose configuration. This experiment to find maximum flow rate and the velocity. For the experiment setup closed loop, firstly, we need to make seed hole on the pipe, and the size for the meter is 0.03 meter. Second, next, connect the pipe loop with the T connector to make it closed loop pipe. These are the result when loop connect with the T connector. Lastly, take the volume of water and time using jug with volume and stopwatch to take the time taken. Conduct the experiment to get the data. Okay, as you see, my friend take the volume of water and we take the time by stopwatch to 3 seconds. This is the result for the experiment. For the whole one, we take the time taken is 3 seconds. For the whole one is we get 70 milliliter. Hole number 2 we get 120 milliliter. Hole number 3 we get 90 milliliter. Hole number 4 we get 50 milliliter. Hole number 5 we get 120 milliliter, and hole number 6 we get 90 milliliter. Okay, to get the maximum flow rate, we using the formula V dot equal to V over time. For the V, volume for the jug, we convert to meter cube. So for the whole one, we get V dot equal to 7 times 10 power of negative 5 divided by 3, and we get 2.33 times 10 power of negative 5 meter cube per second for the maximum flow rate. This is the sample calculation for all the hole to get the maximum flow rate. Next, to calculate the velocity, we should first get the error, cross-sectional error for the hole. Where hole for the radius is 1.5 times 10 power of negative 3 power of 2 and time by pi, and we get 7.068 times 10 power of negative 6 meter square. For the whole one, we conclude to using the formula V equal to V dot divided by area cross-sectional hole. So we get 2.33 times 10 negative 5. We using the V dot, and the area is 7.0 C8 times 10 negative 6. And we get the velocity is 3.296 meter per second. This is the sample calculation, and we using the same formula for the hole 2, hole 3, hole 4, hole 5, and hole 6. These are the result of the sample calculation. Okay, for the explanation of the result, in this experiment, the water flow rate will decrease when the area of connector decrease. The flow rate showing a lower number because the area of pipe connector is smaller. I will pass the next part to my friend.
Assalamualaikum. My name is Muhammad Nasr Aiman bin Muhammad Zulkarnain. My matrix number is B0920102221. And right now I'm going to explain about the NC simulation. According to the task given, we need to simulate two conditions of water hose, which is the first one is straight line water hose, and the second one is closed loop water hose. First, the straight line water hose. Firstly, we need to construct the model, which is we need to construct the two intersecting straight line, which is the first one is 200 millimeters straight line, and the second one is 400 millimeters straight line. After we finish construct two intersecting line, the intersecting point we need to fillet with a radius of 15. After we finish construct the structure, we select the sweep button and select the structure to generate the water hose. Then we click the generate model to generate the model. After we generate the model, we proceed to the meshing process, which is the first. We need to select the inlet and outlet flow. The 200 millimeter straight line will be our inlet flow, and the 400 millimeter straight line will be our outlet flow. Then we click the generate button to generate the flow. As you can see, this is the result. The inlet, the inlet flow, it seems to be yellowish color, which means the flow rate is high. It is in high velocity, while in some point you can see the outlet flow. It seems to be bluish color, which means the flow rate is decreasing or in low velocity. After we collect the data, we calculate the velocity or the flow rate. This is the simulation for the straight line water hose. For the closed loop water hose will be conducted by my partner, which is Mukris Amar. That's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Muhammad Mukasama bin Alias. My number matrix is B0920100012 from Bmmv X1/2. The second type of the hose pipe is the T connector. This is the final geometry sketch. Then after that we need to generate the modeling, and then we need to meshing the T connector, and we need to choose where the part is the inlet and also the outlet flow. And we need in this T connector, we know that one side is the inlet flow, and then at the both two side is the outlet flow, and then we generate the flow. And move to the flow rate T connector, we can calculate the velocity and the flow rate. The yellowish means the flow rate is high, while the bluish means the flow rate is decreasing. And then in the conclusion, to summarize the assignment, the experiment and simulation are able to apply the concept of the Reynolds number which used to determine the fluid flow is laminar or turbulent, and controlling the parameters in all viscous flow. And we also know that from the experiment, we know that flow rate increase, the pressure will be decreased. And after that, we observe that when fluid move at a higher pressure to lower pressure, the velocity will increase. And last but not least, the experiment was successful and the objective are obtained. Thank you.